Hello everyone, and welcome to another podcast in the Space Law and Policy podcast series. I'm your professor, Torres-Spelliscy. Thanks for joining me. The space battles depicted by our entertainment industry, where fighters zip about in zero-G, firing lasers and photon torpedoes, and many other fanciful weapons are still, thankfully, the product of human imagination. Still, there are very real concerns about the militarization of space that policymakers must deal with. Now, to be certain, current regulators do not envision massive battles between competing armadas, the like of which we saw during the age of expansion and colonialism on Earth. Rather, the weaponization of space is more likely to pursue different paths. First, weapons could be placed in space that could be directed at targets here on Earth. Indeed, this was one of the primary concerns of the drafters of the early space agreements, that nuclear weapons would be placed on celestial objects that would then be used to attack targets on the ground. The second type of space warfare that we have to be concerned about relates to the destruction of space assets, either by other space-based assets or by ground-based assets. This means the blowing up of satellites, space stations, and space vehicles. To some extent, we already discussed this phenomenon when we were discussing anti-satellite weapons in early chapters. Now, these two instances of the militarization of space are going to be the focus of our studies this week. First, as we discussed in earlier lectures, the general architecture of space law prohibits the installation of nuclear weapons or other weapons of mass destruction onto any space object. And that means any space object, whether a celestial body like the moon or a satellite. Weapons of mass destruction simply have no place in space. Second, space law expressly limits the use of celestial bodies to peaceful purposes. That means no military bases, no military operations, no weapons testing, and no weapons at all can be placed on the moon or Mars, etc. But you'll notice that the idea of peaceful purposes doesn't include other space objects. You see, even at the earliest stages of space development, it was clear that satellites and other space objects had and would continue to have military applications. Indeed, despite the proclamations that space is only to be used for peaceful purposes, space has always been militarized. From the outset, major parts of the US and Soviet space programs were controlled or influenced by military branches, and indeed the Russian and Chinese programs remain part of their respective militaries. For its part, although NASA is a civilian-controlled enterprise, the United States recently created the US Space Force, which is responsible for, quote, organizing, training, and equipping space forces for the US military. The Space Force is controlled by the United States Space Command, which is a separate military command charged with carrying out operations and missions deemed vital to US space interests. So what do our military assets do in space? Well, their primary purpose is to surveil the ground. But military assets in space could also be used as offensive weapons or even as defensive weapons. From an offensive perspective, it is the satellite fleet of a country that represents one of its most important and arguably its most vulnerable asset. This has led some to conclude that space is, quote, inherently vulnerable and an offensive dominant domain. And with the assets of their adversaries so vulnerable, it's perhaps no surprise that many of the major spacefaring nations have, since the earliest pioneering days of space operations, developed anti-satellite weapons capabilities, known as ASATs. The United States tested its first ASAT weapon in 1959, just a few years following the launch of Sputnik, and the Soviets completed construction of their first ASAT system in 1973. As discussed in previous chapters, other nations like China and India have also conducted ASAT tests. Now, importantly, to date, no country has attacked a space asset of another country. The tests have simply demonstrated a capability to strike by targeting and destroying a country's own defunct or outdated space assets. Now, ASAT systems can include kinetic weapons, non-kinetic weapons, electronic weapons, and cyber weapons. Some of these types of weapons are far more destructive and disruptive to the space environment than others. Let's discuss them in a little detail below. Now, kinetic weapons are the most commonly thought of weapons. Like a bullet or a bomb, they're designed to impact a target with force and cause physical damage. They can be either direct ascent or co-orbital. Direct ascent weapons are launched from the Earth, and they travel to space to reach their intended target. Co-orbital ASATs, on the other hand, are first launched into orbit, and then they are directed toward their target. Now, the problem is kinetic attacks tend to cause significant damage, and they can create debris clouds that can stretch for miles, last decades, and threaten space assets of other countries. Non-kinetic weapons seek to inflict physical effects on satellites and space objects without physically contacting the object. For example, a satellite could maneuver close to an intended target, and then use a laser to either blind sensors or damage components, or it could use a high-powered microwave radiation weapon to disrupt satellite operations. The benefit of these types of attacks is they don't create that large debris field, and the resulting risk of unintentional consequences is relatively low. Electronic weapons like jamming devices attempt to manipulate the way that satellites receive and transmit data, and cyber weapons similarly seek to disrupt the electronic means of communications between the satellites and the end users, seeking to corrupt the data being transmitted or control the system itself. Now, all of these capacities have been demonstrated, and indeed, as I go into detail in the lecture book, many of them have actually been deployed by nations against their adversaries. Turning now to think about defending space assets, we face a more difficult problem. If they are inherently vulnerable, how do you defend them? Well, many of the same techniques that we discussed above with respect to offensive attacks could also be used in defensive maneuvers as well. Things like jamming and spoofing, laser dazzling or blinding, or even physical seizure can all be used against potentially hostile ASAT attacks. You would simply try to employ the method against the attacking object, as compared to the satellite target. Still, this can prove difficult for a couple of reasons. With respect to kinetic weapons, because of the speed at which attacks can occur, they can be hard to defend against unless you have prior knowledge. One of the other options for protecting space assets involves changes to the actual objects themselves. Governments and companies can place shielding, shutters, surge protections, etc. on their objects in order to protect against things like non-kinetic attacks. The problem is that these protections add weight and complexity. As you're aware, weight is one of the most challenging things for spaceflight. The heavier the object, the more expensive it is to leave Earth's gravity, and this is a major drawback to these defensive approaches. So the difficulty in defending space assets has led some to put an emphasis more on passive styles of defense, including thinking about how the system's architecture is constructed. For example, satellites could be launched in constellations or groups that increase the redundancy of the system, and thus protect it through a herd mentality. Even if one satellite gets picked off, the rest of the satellites will continue to serve a purpose, even if somewhat degraded by the loss of the asset. As described in your reading by Harrison, this can be done through a distributed or proliferated constellation. A distributed constellation uses a, quote, number of nodes working together to perform the same mission or functions as a single node, whereas a proliferated constellation deploys a large number of the same types of satellites to similar orbits to perform the same mission. Another option doesn't focus so much on defense, but rather is concerned with a nation's ability to recover. A nation that can quickly deploy and reconstitute its space network is certainly less vulnerable to effective attack. The attack may bring down systems for a few days, but if the nation can replace the damaged satellite quickly, the effectiveness of the attack will decline dramatically. All this means that one of the key determinants of a successful space defense is what's known as Space Domain Awareness, or SDA. This essentially means having knowledge of your environment, so that threats can be identified quickly and countered. In this sense, information becomes the ultimate defensive weapon. Having total SDA can help distinguish between actions which are benign and actions which have the potential to be hostile. This could be critical in diffusing volatile situations and in preventing conflicts from escalating where unnecessary. SDA systems include both ground-based and space-based assets to monitor the position of space objects and other launches. So as space becomes increasingly integrated into human society and begins to play an increasingly important role in all aspects of our daily lives, our vulnerability to disruption also grows. A well-placed attack by an adversary could cripple critical systems and throw society into disarray. So the key question for policymakers is how to successfully defend these important assets. There are no easy answers here, but a treaty that clarifies the importance of space assets and offers them some level of protection might be a good starting place. In particular, a treaty that bans the use of ASAT weapons would serve a significant purpose. As discussed in the lecture book, some preliminary steps have been taken toward that purpose, sponsored primarily by the US, but key players including China, Russia, and India are resisting. So how to get a resolution that protects our space assets will be a key test for policymakers in the generation to come. Well, that does it for this week's edition of the Space Law and Policy podcast series. I'll see you next week, and thanks for joining me.